Hi grade 12s. In this short video, well maybe short video, we'll see how long it is, we're going to do two of the circuit analysis questions from that assignment. It was question 35 and it had A, B, C, D, and E, and maybe even an F, I can't remember. But we're going to do D and E because they were the hardest of the two. And so what I've got here on the board behind me is the drawing and the setup for question D on that assignment. I've drawn this just slightly differently. Okay, on their diagram, they had R3 sitting up top here and then connecting with R4. It doesn't matter which way you draw it. R3 and R4 are in series. There was one line between them and they are in parallel with R2. So it's just important when you're doing these to recognize what parts are in parallel and what parts are in series. Now, when we have a setup like this, and here is our setup, we have all the resistances, we do have a current, we could find this potential difference. We'll do that in a moment. But the biggest issue, the biggest thing that we're going to have to find, where the most work comes in, is we need to find this R total. All right, and because we have all the resistances, we can do that. But it is a combination of series and parallel parts. And so we have to think of equivalent resistances. You did a bunch of questions previously where you were finding the equivalent resistance if we had this many resistors in parallel or this many resistors in series. And so we want to do that, but it does require us to combine some things together. So the first thing we're going to do is we are going to combine R3 and R4 together. We're going to make an equivalent resistance there. All right, so combining R3 and R4, now that's pretty simple. We're going to call this here, we're going to call it RE1. Resistor equivalent 1. All right, and we're doing 1 because we're going to have 3 equivalent resistances when it's all said and done. All right, so RE1, we'll just write it up here. RE1 is R3 plus R4. Again, this is one you could do in your head because they're in series, which means we're just adding them together. 5 ohms plus 15 ohms is 20 ohms. All right, so that's that. Now what we're going to do is we're going to combine that equivalent resistor. Now this R3 and R4 is equivalent to a 20 ohm resistor that is in parallel with R2. All right, so we're now going to combine those together in this red circle, and we're going to call that RE2. Okay, so RE2 is going, sorry, they're in parallel now, so it's not RE2, it's 1 over RE2 will equal 1 over R2 plus 1 over RE1, the equivalent resistance we found for 3 and 4. All right, so let's plug in our numbers here. 1 over RE2 equals 1 over 10 plus 1 over 20. And we're going to add those fractions together and we're going to get 3/20ths. But that's 1 over RE2, so RE2 is equal to 20 over 3 ohms or 6.67 ohms. Okay? All right, so that is the equivalent resistance for this section, this parallel section. This section is in series with R1, right? R1, the current comes through R1 and then it comes through this parallel part. So the parallel part is in series with R1. So now to find our total is going to be R1 plus RE2. Okay, so our total is R1 plus RE2, or what was RE1? R1 was 25 plus our 6.67, and we get 31.67 ohms. All right, so that's what number is going right here, 31.67 ohms. All right, now once we have that, now we want to work backwards and we want to figure out what we can out of here. So let's start with this. 3 amps times 31.67 is about, we're going to multiply that because V equals I times R. So this will give me 95 volts there. 3 amps times 25 ohms gives me 75 volts there. All right. Now, that leaves us with 20 volts, right? So there's 20 volts going into this part, all right? And that means that on each side of this parallel piece, there has to be 20 volts. So that means there's 20 volts here in R2, and R3 plus R4. So V3 plus V4 has to equal 20 volts. All right, so we can't do that yet. We got to figure out what the combination is. But from this information here now, we can find I. I equals V over R. So V divided by R is going to leave me with 2 amps. And if I have 2 amps going this way, that means I have to have 1 amp going that way. 1 amp. They're in series, so they're the same. That's also 1 amp. And now I can find V3 and V4, where I will get, again, it's I times R. And you see here that V3 and V4 add up to 20 volts. All right, so we have all of our laws combined here. We have filled in the chart, which is what we want to do. And the hardest part about this is finding this R total, because you have to recognize where you have to find equivalent resistances. All right, and so again, we started by combining R3 and R4 together to get an equivalence. We then did R2 plus that equivalent one, and then R1 plus the equivalent one, and that allowed us to find R total. Once we have R total, then the math gets pretty simple, because then we're just filling things in. And then here we're remembering Kirchhoff's laws in terms of how voltage works and how current works in a parallel circuit and series circuit. All right, we're going to do question E. Question E is similar, but it has even more resistors. It has 6 resistors and a few more equivalent parts that we're going to have to find, but it's again the same math. So let's go do question E. All right, here we have part E, question E on this one. And so again, here's our setup. I've tried to draw the diagram the way it was. We have 150 volts potential difference here. R1, 2, 3, 4, 5, and 6 down here on the bottom. And so when we look at this, again, we have to determine where are we going to have to find our equivalent resistances. So here's our setup here. And again, the first thing that we're going to want to find, that we have to find, is our total. It's the only thing we can find because that's all we have is resistances. So we're going to find that. All right, so the first thing we're going to do is we're going to take a look at R2 and R3, and we're going to call that RE1. And then secondly, we're going to look at R4 and R5, and we're going to call that RE2. And then we're going to combine the whole thing together, and we're going to look at this whole section here, and we're going to call that RE3. All right, so let's start by finding RE1. So again, we're going to come over here. They are in parallel. R2 and R3 are in parallel, so 1 over RE1 is 1 over R2 plus 1 over R3, which equals to 1 over 1 plus 1 over 15, which gives us an equivalent resistance of 16/15. Okay, and I'm going to leave it like that. That's 1 over RE1. I'm just going to leave it as 1 over RE1 because we're going to need it when we do the parallel part for RE3. We're going to need 1 over RE1, and we're going to need 1 over RE2. We don't need RE1 and RE2. All right, so now let's find, I'll do the different color here. Let's find 1 over, let's find RE2 right in here. RE2. So we're again, same thing, 1 over RE2 equals 1 over R4 plus 1 over R5. So 1 over RE2 equals 1 over 10 plus 1 over RE5, 1 over 1, and that gives us 11/10 ohms. All right, and now we're going to combine those two into this large circle. We're going to find RE3. Okay, so again, we're going 1 over RE3, but now that equals to 1 over RE1 plus 1 over RE2, which equals to 16/15 plus 11/10, which equals to, what do I have here? 13/6. Okay, which we're going to flip over, and we're going to get RE3 equals to 6/13, or as a decimal, which is what we need here, 0.46 ohms. Okay, so that's that. Now we need to find, now we're ready to find our total. Okay, our total is now RE1 plus the resistance from this section, which is 0.46, plus R6. All right, so that's going to be our total. So I'm just going to do that right here. Okay, our total will equal to R1 plus RE3 plus R6, or RE1 was 5 plus 0.46 plus 20. All right, and that's pretty simple to find, 25.46 ohms. And why is there an extra dot? There we go. All right, so that goes here, 25.46 ohms. All right, so now with that, we're ready to start finding some things. So we can find I. Okay, I total. I is V divided by R, so 150 divided by 25.46 gives us 5.9 amps. Okay, now R1 is in series with that, so it's 5.9 amps. R6 is in series with that, it is at 5.9 amps. Okay, that allows us to find V1. V1 is I times R, 5.9 times 5, 29.5 volts. Okay, down here, 5.9 times 20 is 118 volts. Okay, moving on. That leaves us with, so now we have start with 150. We have a 29.5 volt drop here, and we have an 118 volt drop here. That leaves us with only 2.5 volts to be used in this section. And R2, R3, R4, and R5 will all have the same potential difference because of Kirchhoff's voltage law. This is the drop for this section. So these are all 2.5 volts. And with that now we can find I, because again, I is V over R, and we can fill in these numbers. So this one is 2.5 amps. This one down here is 2.5 amps. Those are the easy ones, but really not that bad. 2.5 divided by 15 is, oh, I can't read my own writing. Looks like 0.67 amps. And finally, can't tell if it's a 2.5 or a 1.5. I'll get 2.5. 0.25 amps there. All right. So once we get our total, things start falling into place, right? We found the current here using V equals IR, or in terms I equals V over R. Once we have that, anything that's in series with this has the same current. So that was R1 and R6. Once we had those numbers, we could find V1 and V6. And then we did 150 minus 29.5 minus 118. That gave us the 2.5 volts for the parallel section. Once we had the voltage there, all that left us with was the current. All right, so the key to these questions, the key to circuit analysis, is being able to find R total. Once you have R total, everything else generally falls into place nicely just using Ohm's law. All right, but it's a matter of recognizing what's in parallel, what's in series, and using the appropriate laws. Hope that helps. I know they're difficult. This is probably the most difficult one you'll see. Might be one other one that would be similar in difficulty, but this is what you have to be able to do in order to do circuit analysis. All right, hope that helps. If it doesn't, send me another email. We'll try to figure out another way to show you, or just do more and more examples, because that's what will help you figure this out. Have a great day. See you later.